Welcome to NIOS live classes. Subject Science and Technology. Class 10, book number 212, module number 2, Matter in our surroundings. Lesson number 3, and the topic is atoms and molecules. Part 2. After study this lesson, learner will able to know what is atomic mass and atomic mass unit. And second, they can define isotopic mass, atomic mass and atomic number. The topic atomic mass. In general word, we can say atomic mass is the weight of an atom. A scientist named Dalton introduced the idea of atomic mass. He said that every element is made of tiny particles, which is called atoms. He said that atoms of the same element have same atomic mass, and also atoms of different elements have different atomic masses. Each element has its own kind of atom, and each kind of atom has its own weight, and this weight is called atomic mass. In short, AM. Dalton could not weigh one atom because atoms are too small and are unable to see through our naked eye. So instead, he compared the masses of elements that join together to make a compound. As you can see, there is a visual representation of atomic mass, which is first is one oxygen atom at 16 mass unit and 2 hydrogen atom at 1 mass unit. Combining them, we can get one water molecule at 18 mass units each. Dalton used these weight comparisons to find relative atomic masses, which means how heavy one atom is compared to another. For example, there is a 1 gram of hydrogen which reacts with about 8 gram of oxygen to make water. We know the formula of water is H2O. In it, there are 2 hydrogen atoms and 1 oxygen atom. And combining them, we can get our water, which is H2O. Here is a visual explanation of that example. It shows 1 gram of hydrogen, which is 2 hydrogen atoms, and 8 gram of oxygen, which is 2 atoms. This shows that one oxygen atom is much heavier than one hydrogen atom. In simple words, we can say, by comparing the weight of elements that join together and using the formula of the compound, Dalton found the relative weight of atoms. Dalton did not know how many hydrogen and oxygen atoms join to make water. So he made a simple guess that one hydrogen atom combines with one oxygen atom. And because of this guess, he thought that one oxygen atom is about 7.9 times heavier than one hydrogen atoms. Later, some other scientists found that this guess was wrong because water is actually H2O, combining two hydrogen atoms along with one oxygen atoms. In simple words, Dalton assumed the simplest combination, but his assumption about water was not correct. Because we know that water has twice as many hydrogen atoms as oxygen atoms. So that's why its formula is H2O. So the relative mass of one oxygen atom must be 2 multiply 7.9, which get 15.8 times the mass of one hydrogen atom. After Dalton's work, scientists calculated relative atomic masses of many elements using hydrogen as the reference. For example, water, which is H2O, and ammonia, which is NH3. Later, hydrogen scale was replaced by an oxygen based scale. Because oxygen is more reactive and forms many compounds. There is a picture showing early hydrogen scale and after it replaced by oxygen scale. The hydrogen scale was one of the earliest methods used by scientists to measure atomic masses. Hydrogen was chosen as the standard because it is the lightest element, and the atomic mass of hydrogen was fixed as 1 unit. The atomic mass of all other elements were then compared with hydrogen. So, if an element was 10 times heavier than hydrogen, its atomic mass was written as 10 on the hydrogen scale. Let's take a short break. Welcome back to our classes. We know what is hydrogen scale, and later it has been changed to oxygen based scale. Scientists later stopped using hydrogen to measure atomic masses because hydrogen was difficult to handle and measure accurately. Instead, they use oxygen as the standard element. And the atomic mass of hydrogen was fixed as 16 units. Hydrogen was selected because it reacts easily with many elements and can form compounds which is called oxides. This made it easier and more accurate to calculate and compare the atomic masses of other elements. Mass spectrometer. In 1961, scientists adopted a new atomic mass scale, in short AMS, which is called the carbon-12 scale or C12 scale. In this scale, the atomic masses of elements are measured using a machine called a mass spectrometer. A mass spectrometer is an instrument that can measure the mass of atoms very accurately. This instrument was invented in early 90s and helped scientists get more precise and reliable atomic mass. As you can see on the screen, there is a picture showing mass spectrometer. There are various stages through we get the atomic mass, like vaporizers, electron beam, ion accelerators, magnets, and at last Faraday collector. Scientists compare the masses of all atoms using a standard atom. This standard atom is carbon-12, an isotope of carbon. The mass of one carbon atom is fixed as electrically 12 atomic mass unit, which is, in short, we can call it AMU. One atomic mass unit, which is 1 AMU, is defined as 1/12th of the mass of carbon-12 atoms. This small unit helps scientists measure and compare the masses of very tiny atoms. And today, atomic mass unit is also called unified mass unit and written as U. There is a picture showing adoption of carbon-12 atomic mass scale in 1961. The relative atomic mass of an element, when written in atomic mass unit, is called its atomic weight, which is AW. And today, scientists mostly use the term atomic mass instead of atomic weight. John Dalton said that all atoms of the same element have the same mass. Later, scientists discovered that atoms of same elements can have different mass. And these different forms of same elements are called isotopes. And the atomic masses we use in reactions or chemical calculations are average atomic mass. These averages depends on how much each isotope of the element is present in nature. Now let's learn some glossary words throughout this part. First is element. Element is a pure substance which is made up of only one kind of atom. For example, hydrogen. It can found in water and fuels. Second, oxygen, which is needed for breathing, and carbon, found in all living things. Second is atom. If you keep breaking an element into smaller and smaller particles, at last that smallest piece, which is can't be able to see through a necktie, is called an atom. Next is nucleus. Nucleus is the center of the atom. It contains two charges, which is positive and negative, also called protons and neutrons. As you can see, there is a picture showing atom and nucleus. Next is electrons. They move around the nucleus and electrons have negative charges. There is a picture showing the electrons. They are very light compared to protons and neutrons. Now there are easy way to remember these processes. First is atom, which is whole structure, and then comes nucleus, which is center of the atom. Then comes proton and neutron inside the nucleus, and last electrons, which is moving around the nucleus. Now we will start our next topic, which is isotopes and atomic masses. Isotopes are atoms of same element. They have the same number of protons, so they are the same elements. But they have different number of neutrons. Because of this, their masses are also different. The atomic mass of an element is not the mass of just one element. It is the average mass of all the isotopes of that elements. These average depends on mass of each isotopes, and second, how commonly each isotope is in nature. Let's take a short break. Welcome back to our classes. Now we will learn what is isotopes and atomic masses. 3.2.4. Dalton believed that an atom was an invisible particle. Later, scientists discovered that an atom is made of smaller particles, electrons, protons, and neutrons. An electron has a negative charge and a proton has a positive charge. In an atom, the number of electrons and protons are equal. Because of their charges are equal, opposites the atom becomes electrically neutral. And protons are found in nucleus, which is at the center of the atoms. Electrons move around the nucleus. There is a picture showing the arrangement of electrons around nucleus in hydrogen, and second in carbon, and third in oxygen. The number of protons in nucleus is called atomic number, which is denoted by Z. For example, oxygen has 8 protons, carbon has 6 protons, hydrogen has 1 proton, so their atomic numbers are 8, 6 and 1. There are also particles in the nucleus with no charge, which is called neutrons. The mass of proton and a neutron is almost the same. There is a picture showing the structure of an atom. An element may be defined as the substance where all the atoms have same atomic number. Atoms of same element always have same number of protons. but they do not always have the same number of neutrons in their nuclei. Because of this difference in neutron count, atoms of same element can have different masses. So we can get the mass of nucleus through adding the protons and neutrons. The total number of protons and neutrons is called the mass number, which is denoted by A. The atomic number is written at the bottom left on an element symbol, and the mass number at the top left. For example, there is a symbol which is showing carbon. So it has carbon atom and it has 12 particles and 6 protons. So number of neutrons will be 6 neutrons. In the same way, the symbol of oxygen means an oxygen atom has 8 protons and total of 16 neutrons. So oxygen has 8 protons and 8 neutrons, so it will be 16 nulons. Because an atom is electrically neutral, the number of electrons is equals to number of protons. The atomic number, which is denoted by Z, tells us the number of protons in an atom. And this atomic number helps in identifying one element from another. For example, all oxygen atoms have 8 protons, but they may have different number of neutrons. One type of oxygen atom has 8 neutrons and other has 9 neutrons, and a third type has 10 neutrons. These are the written form of that oxygen atom, which is oxygen with 8 protons and 8 neutrons, then oxygen with 8 protons and 9 neutrons, then oxygen has 8 protons and 10 neutrons. there is a visual explanation of it. Atoms of the same element that have same atomic number, which is Z, but different mass number, which is A, are called isotopes. Because isotopes have different masses, we use average atomic mass, which is AAM, for elements. The average atomic mass depends on how much each isotope is present in nature. For example, chlorine is obtained as a mixture of two isotopes, and these isotopes are present in the ratio of 3:1. So, what will be the average atomic mass of chlorine? And solution. So, there are two chlorines present in the ratio of 3:1. That is, out of 4 atoms, 3 atoms are of mass 35 and 1 atoms of mass 37. Therefore, we will get the average atomic mass through combining them with divided by 4. So, we get, after calculating, we get 142 upon 4, and total overall we get 35.5 atomic mass. Here is a table showing some elements, their symbol and their mass. We have completed this part. Thank you for paying attention.